Okay, so if you're graphing a polar equation in ALEKS, let's first start off with what polar coordinates look like. Okay, you're given an r and you've got theta. Instead of taking x and y is what we're used to seeing, like this, right? X tells you how many spaces to move on the x-axis. Y tells you how many spaces to move up on the y-axis. But r in polar coordinates, we're talking about the radius, is the distance from the center, okay? So if this distance here is 2, and then we made the equation of a circle or some other figure, if the distance from the center is 2, then r equals 2. Okay, it's not always equations because sometimes r is a variable or sometimes r fluctuates based on theta. Okay, but r means the distance from the origin, and then theta represents the angle of rotation. So if you have the polar coordinate 2 comma pi over 2, okay, so pi over 2, we know that's 90 degrees. So we start on our usual initial side right here, and you rotate 90 degrees to get here. And then we're at 2 for the distance from the center, distance from the origin. So 2 pi over 2 is this point right here. Okay, because we're 2 away from the origin, and then we rotate an angle of pi over 2. And then one more point for good measure here. Let's just do 1. Let's do 4 pi over 3. Okay, if you convert from radians to degrees, if that's the way that helps you graph points, 4 pi over 3, that's 240 degrees, right? I'll give you a second to double check here. Probably too late at night for me to be doing that. Yeah, 240 degrees. Okay, that lands us somewhere around in the third quadrant, and then we're 1 unit away. So if this distance here was 1, this would be 1 comma 4 pi over 3. It's 1 distance away from the origin, and it's a rotation of 4 pi over 3. All right, so now that we have that, we can try to graph this stuff in ALEKS. Let me clear the board. Okay, so actually the second one's probably easier. Let's start with that. R equals -2. Remember when you graphed other stuff like x equals 2, that graph was here. Here's where x equals 2 on the x-axis, but this is 2 comma 1, this is 2 comma 2. These are all the points where x equals 2, right? So we're going to do the same type of thing to graph B here. Okay, we're going to make dots for all the places where r equals -2. So r equals -2. Yeah, so with the negative sign, okay, the example I did at the beginning, that's an r of +2 means you just go 2 units away. An r of -2 is still 2 units away from the origin, but it's just in the opposite direction of whatever angle you're dealing with, okay? But in this case, we don't have an angle. This is r equals -2 regardless of theta, okay? So let's find out where r could equal 2. Okay, r equals 2 here, so that means r equals -2 is here. Okay, so -2 distance from the center would be here. That's for like a degree of 0. You know, if theta is pi over 2, then r should still equal -2. Okay, so if we have -2 comma pi over 2, well, 2 pi over 2 would look like this. It would be a dot right here, 2 away from the origin, and then pi over 2. See how ALEKS has it up here. Pi over 2 is the angle. But -2 for the radius just means you go in the opposite direction, so put a dot there. But we could also plot this point, 2 comma pi over 2, because this would be the same thing as doing 3. We could say this is negative, and that's 3 pi over 2. All right, so 3 pi over 2 is down this way, but -2 means we go the opposite direction. Okay, it's probably pretty confusing what's happening. It's because the negative sign just means you need to go the opposite direction of whatever the angle says. But basically, if you see r equals -2, that means put dots wherever r equals 2 as well, okay? So r is the distance away from the center. So that's 2 away, that's 2 away, that's 2 away. This whole circle represents being a distance 2 away from the center. So on ALEKS, we need the circle tool. Place the first point, place the second point. That should do it. Okay, so that one was kind of a confusing one, I guess, to start with, because -2 it's still 2 away from the origin. The negative sign just means you need to go the opposite direction of whatever given theta you have. But for b, we're doing it for all thetas. That's why I made that whole circle. Okay, now for a, one thing, there's different techniques for doing it, but one thing I like to do is rearrange the equation by getting theta and r separated. Okay, so I divide both sides of this equation by r. And now let's think about some points that could happen here, okay? Remember, it goes r comma theta, okay? So if you plug in 4 in for r, this becomes cosine theta equals 1, right? 4 divided by 4 makes 1. So think about all the places where cosine is 1, okay? On the unit circle, cosine is always the x coordinates. So this is 1 comma 0, right? This point right here that I drew, that's 1 comma 0. So that means that when theta is 0, cosine equals 1. So when r is 4, we got this equation. And that's only solvable when theta equals 0.